All right, what I want to talk to you guys about today is something called concentration, which is right here. And really, concentration is a measure of how much solute to solvent that you have. And there's many ways that we use concentration. We can measure concentration or express concentrations. One way is a mass percent. However, we're not going to talk about that so much this unit. It's one of the things that we've taken out. But the one that we are going to talk about is this one right here, capital M, which stands for molarity, not to be confused with molality, which we will do at another lesson, little m. So this has to do with something called colligative properties that we'll cover later on in the week. But capital M, molarity, is a measure of concentration that we're going to learn about today. You also may have heard of something called ppm, which stands for parts per million or parts per billion, ppb. Those are also concentrations that you may encounter if you're doing any research with drinking water and you're finding out what allowable limits are for, like, say, how much lead you can have in the drinking water or how much copper is in a drinking water. Those are typical units of measure of concentration. What that stands for is parts per million. So that would mean you have 1 part of the solute for every million parts of water, or 1 part of the solute for every billion parts of water. So those are typical concentrations as well. Molarity is defined as moles over liters, and you guys may have heard us talking about this. We've used it in class before, even though we haven't completely defined that. Molarity stands for moles per liter, and you can calculate a molarity and by just taking the moles of you might have grams, you'll have to convert it to moles, but then here's the key: it's always in a liter of solution. Okay, so let's take a look at this problem right here. It says calculate the molarity of a solution made by dissolving 1 gram, and this should say of ethanol, in enough water to give a final volume of 145 milliliters. How would you solve that problem? How would you calculate the molarity? Well, the first thing you're going to have to do is take that 1 gram of ethanol and you're going to have to convert that to moles. Giving you the formula here, you should be able to calculate the molar mass and convert that 1 gram into moles. So let me just show you the work that you would do here for that, okay? So you notice I took my 1 gram of ethanol. The molar mass of ethanol is 46.07 grams. Grams go on the bottom, 1 mole goes on top, and then that would equal 0.01 or 0.0217. That's just a marking there, okay? Now, this would be the moles that would go in the numerator, right? But then in the denominator has to be liters. So you have to convert that 145 milliliters into liters. So that's 0.145 liters. When I do this work, you'll notice that I come up with 0.150 capital M, or 0.150 moles per liter. I would accept either unit for molarity for that. Okay, so molarity calculations are pretty simple. You just have to get it into moles and then remember to divide by liters of solution. Okay, but that is a point that I should make, is that, remember, a solution is the solute and the solvent combined there. So that's something to remember. Okay, so how do you make a molar solution? Well, you would need to calculate how many moles you would need. So if you know the moles, you'd have to figure out how many grams that's related to, and you'd weigh out that certain amount of salt. You then transfer it into this thing that's called a volumetric flask, and it is a lot more precise than a graduated cylinder. And then what you would do is that there's a specific little marking here, right here is the mark, that you just keep adding water till you get to that mark. And then you would have precisely, in this case, this is a 1 liter volumetric flask, you would precisely have 1 liter. Now these volumetric flasks can come in a liter, they can be 500 milliliters, you could have 100 milliliters, you can even have little tiny 10 milliliter ones, so they come in various sizes. And that's a simple way that you just, basically what you're going to do is you take a salt from the storeroom, you measure out how many moles, and then you would put that in here, add enough water for it to be a liter, and you would have a liter of solution, and you would have a known molarity. Okay? All right, that gets us to talking about concentrated versus dilute. Okay, 2 terms that you should know. What does it mean to be concentrated? So here's a picture of, it looks like some red dye, and you can see the cup way on the right is concentrated compared to the cup on the left. Okay, so this would have more particles of red dye than what's over on the left, which is just showing that really light pink color. So what it means to be concentrated is that you have a relatively high solute to solvent ratio. So this is another picture of what we would call a concentrated solution here. You can see there's a lot of solute in that given ratio and given amount of solvent. Okay, so that's what we would call a concentrated solution. Compared to what a dilute solution is a relatively low solute to solvent ratio. So as you look here, this is a dilute solution where you can see you don't have as much solute to solvent ratio. So there are times when you would have to make a dilution from a concentrated solution, and that happens as a chemist. And we have a pretty handy little equation to use that we call the dilution equation. It's a process of adding more solvent to what we call a stock solution, which another name for a stock solution is indeed, we could call that a concentrated solution. So when you hear the word stock solution, you can think of that as being a concentrated solution. So this is the equation we use, M1V1 equals M2V2, where M stands for molarity and V stands for volume. Okay, so this is typically your more concentrated, the M1 is concentrated, concentration, and M2 is typically your more diluted concentration. And I'll show you an example on that. How you would make a dilution? Well, you would use this thing right here, which we call a pipette. And so you would take a given amount of a concentrated solution, I don't know if you can tell, but that's really kind of a darker green, and you would measure a certain amount out, and you would put it into a volumetric flask, add water to the line on the volumetric flask, and you have a diluted solution. That's how you make them, okay? So here's an example. What if, what volume, it's asking, of a 12 molar hydrochloric acid solution must be used to make 7.5 liters of a 0.25 molar hydrochloric acid solution? So this is my concentrated, because it's a higher molarity value. So this is my concentrated value. So I'm going to put that right here in M1, and V1 is, we're trying to solve for that. We don't know how much that is, right? That's what we're looking for. And my M2 would be my more diluted concentration, 0.25, and my V2 would be my final volume, the 7.5 liters, okay? So to solve this, I'm going to take 0.25 times 7.5 and divide it by 12, and I would know the volume of that 12 molar solution I would have to put in into a 7.5 liter volumetric flask. Okay, so that is the calculations, and you'll see some homework problems for both molarity and using the dilution equation as well. I think this is a good place to stop. The next lesson is going to be about stoichiometry. We'll see you then.